Okay, perfect. It is 3:02, so we're going to get started. Thank you all so much for coming to our Q2 meeting at the Denver Tug. Just a couple of housekeeping items today. We'll start off with some announcements, and then we have two speakers, Jim Dehner presenting on 0 to Zen, LODs and table calcs. I'm really excited for Jim to present. I saw him present at a DataFam event a couple of years ago on calcs, and it was super informative for me. And I still refer back to the presentation today all the time. And we'll also have Jupiter Angulo from Salesforce presenting on some Tableau updates. So getting into a couple of our housekeeping items. First up is Tableau Conference. That's coming up next month, pretty soon. If you're going in person, I hope you have your hotel and your flight booked already. If not, and you're still interested in going, I believe you can still register for in person. There's also a virtual option, time zones all across, but I just took the screenshot as the Americas time zone. It's going to be May 17th to 18th virtually. There's a component, I guess, on the 19th that's in person that is not virtual. And you can also register to win a Vegas VIP experience. So if you haven't gotten your in-person ticket yet and you're interested in going, worth it to register. You never know if you're going to get lucky and win. And next, some sad news. We are going to be going on a hiatus. I'm not saying we're going away forever, but we are the current leaders will be going on a hiatus. So if you are interested in becoming a leader of the Denver Tug, please reach out to me. I'll put my email address in the chat. We would love if anyone would like to step up and take over leadership. Otherwise, we may come back in the future, but currently we just don't have the time to be able to make the time commitment for all of you guys. So this will be our last event until we come back. But there are some other options. There's the Rocky Mountain Tableau user group. They have been fairly inactive, but they just had an event this afternoon. So I believe they are coming back with more events. And there's a bunch of themed groups. When we send out this, the PowerPoint or the slide deck, these links will be attached, but I'll also drop them in the chat. Themed groups, there are a ton of them, depending on what kind of lens of Tableau you are into. I know Jim runs a Tableau newbies group that's really active, and there's a bunch of other groups, some like special interest kind of groups. So a lot of options outside of just our Denver Tug. It's been wonderful to present and work with all of you and get to meet you. I'm really sad to be going on hiatus, but it's just the choice that we all have to make at this point. So with that being said, again, if you are interested, please reach out. Even if you just have questions, I'm happy to talk to you about kind of time commitment, responsibilities, and just as a plug, it's really great for your resume. And I was able to get my current job partially because of the leadership that I was doing with this. So again, if you have any questions, just reach out to me over email. And welcome to our two presenters. We will be starting off with Jim. I have a couple of bullets here about him. He is the owner of Market Analytics and a BI consultant. He is a tug leader, I believe, of a couple tugs, and a 5-time Tableau ambassador and a Zen master, a really amazing person to learn from. And Jupiter, he is a lead solutions engineer at Tableau. Jupiter, I couldn't find any other bullets for you. So when you present, feel free to kind of like intro yourself with a bit more depth. But with that, I will turn it over to Jim to start sharing his screen.
Okay, you should be able to see my screen now. And if somebody could just give me a verbal yes, we can see it, get started.
Yep, we are all set.
Okay, great. Hey, Denver, thank you for allowing me to speak today. I'm really glad to be here. Today, we're going to talk about LOD expressions and table calculations. And I know that those can be difficult for some, and I know I certainly had my problems with them when I first got started. First, just a little bit about me. We are now called data or Tableau visionaries. The term Zen Master has been replaced by Tableau visionaries, and this is what the new logo looks like. And you'll be seeing it if you go to convention. You'll be seeing it, or you'll be seeing it out on the forum or the community sites. I do happen to be one of the data visionaries. I was a Zen Master last year, so I'm a Zen Master and now transitioned into a data visionary. I live in Nashville, or actually live outside of Nashville, where I do some consulting work. It's kind of important for you to understand that I am not a data scientist and I am not an IT person. I'm an engineer. I've got a business degree, and I spent most of my time in business working as a product manager or a business unit manager with consumer products companies. And about 5 years ago, a client that I had came to me and he said, look, I want you to learn Tableau because we're going to use it for reporting. And he said, understand, it's very easy. It's just like Excel. And you and I both know that that's not the case at all. And at first I struggled. And what you're going to see today came out of that part of that struggle in the things that I really had to learn to do before I felt comfortable using Tableau. Since that point, I've been a 5-time forum ambassador. I'm a data visionary. As noted, I co-lead the Nashville Tug Group, and I also co-lead the newbie groups. And I hope some of you have been out to the newbie group. We meet on about a very 6 to 8 week cycle. Our next meeting is May 26th. And you can find that out at the user group hub. You can sign up for that meeting. We have a tug that's dedicated. We talk about newbies, but we're talking about people who are relatively new to intermediate users of Tableau, and they want to learn more about how to use Tableau. Now, what you're seeing today came from a series that I did about a year ago. It was called Zero to Zen. It was a 5-part series. And I had to put this together. Like I said, when I started Tableau, I came from an Excel background. I didn't really understand the terminology that was used in Tableau, and it was pretty difficult to start. And I found there were 5 things I really had to understand before I could use Tableau effectively. And we started with data structure, and then probably the most important thing you'll ever learn in Tableau is the order of operations and what sequence Tableau goes through as it creates each one of your worksheets. The third session, we looked at syntax, and today we're going to look at half of the calculation segment that I put together in the last of the 5-part series, pertaining to what I call the toolkit of filters, sets, and parameters. That's what users use when they interact with your workbook. But today we're going to look at 2 of the 4 basic types of calculations. There's only 4 types of calculations in Tableau. There's simple calculations, date functions, and then the 2 that we're going to look at today are LOD expressions and table calculations. Now, I want to start with LOD expressions. And I want you to think about your data as a pyramid. And the data that you enter into Tableau at the lowest level is, that's what the data scientists refer to as a grain. I just refer to it as the lowest level of data. And that data, think of that as the base of your pyramid. And when you bring a measure to your viz, it gets aggregated, and it gets aggregated as a default as a sum. But it could be a different aggregation. You could decide to aggregate it as an average or whatever, but it gets aggregated as the sum. So you can think of the data at the bottom of your pyramid as the data that you entered, and the data at the top of the pyramid is that data that got aggregated as you put it on the viz. But I found that very often I like to have other levels of data in my data set. Data that I can call on and I can use in calculations. And that's where fixed LODs fit in, because you can create virtual layers in your data set, and then you can use them in other calculations. LODs, fixed LODs are not aggregates in themselves, so they can be treated like any other data. Now, if we take a look at how you write an LOD, and I'm going to try to use this pointer. All LODs start and are encased in a curly bracket on each end. And then there's a code word. And when the code words are fixed, include or exclude, and we're primarily going to talk about fixed today. And that's followed by a list of dimensions that are separated by a comma, a colon, and then a way to aggregate the data. Now, I like to think in how you would say this in words. And if you take a look at this expression, you think about making all the combinations of these dimensions. You take all the combinations of regions, and there's 4 regions, and take those with the 3 segments. So 4 times 3 is 12. So all the combinations of region and segments are 12 data points. And you sum all the sales for each one of those 12 data points and store it and save it so you can use it later. That's what's going on with this calculation. And we can take a look here and we can say, well, okay, that's that same calculation, and I've just written it out, and it totals these 12 values. Well, let's take a look at what that data actually looks like. I'm going to open this up. Okay. And if you haven't seen it, this is the new view of the summary table in your full data table. This has changed just with the introduction that came in about a week ago. Okay. But as you look at this table, you can see there are 12 rows. And you say, well, wait, there's only 4 rows. That's not 12. Well, think about the way Tableau likes to look at data. It's like narrow and tall data sets. And we take a look at this combination of regions and segments. So what we're doing is we're taking a look at the combination of the individual values of region and segment to get these 12 values. And then we're summing the sales. Well, this is the sum of the full data set. And if we take a look at the full data set, there's 10,000 rows in this data set. We're taking those 10,000 rows, and every time we have a combination of South and consumer, for example, we're adding those values together, and the total of all those combinations equals 195,000. And the same for each of the rest of these. So what we're doing when we do this LOD expression is we're creating a layer at a different level in our data set. That's the aggregation of the detailed data from your data table as you create the table that's in your viz. Okay, well, what can you do with this stuff? Let's start taking a look at how this data can be connected and what you can actually use this data for. I'm sorry, I just have to move one of the control bars out of the way here. Okay, we're going to take a look at the data set that I created. It's just a very simple data set. It doesn't have 10,000 records in it. Matter of fact, it's got very few records in it. And all I've got product lines, and I've got products, and I've got customers, and I've got colors, and it looks something like this. And one of the things you need to know is that if we put a total on this, the total is 152 is the total quantity in this data set. Now, in this data set, what I'd like to do is I'd like to add a couple of LOD expressions, and I'd like to put a couple of additional layers in the data set. The first is just a very simple fixed at the product level sum of quantity. And all this expression does is we're going to take a look at each product by itself. And I got a product here, Sport 1, Sport 2, and Toys 1 and 2. And at that product level, I want to sum the quantity. And if I take the sum of these 5 values, it's going to equal 39. And that's what we see here in this column. And the sum of these two is 24, and so on. And I want to add another expression in here. And we're going to take a look at the customer and the product level, the combination of these 2 values. We're going to take the sum of quantity, and we can see here for the first one, the value is 25. The quantity 3 plus 22 is 25, and that's true for all of this combination of customer and product. And then the second customer, the value is 14, and so on. Well, what we've done in doing this is we created 2 additional layers in the data set. We created a customer product level, and we created a level at the product level itself. Well, I want to show you one additional thing here and open this up. So let's take a look at how that looks in the data set itself. I keep saying we've added layers to our data set. Well, if we take a look at the full data set, we've actually dropped 2 additional columns in the data. We've restructured the data set to include 2 additional columns, one at the product level and one at the customer product level. So now instead of just having quantity in the data, we've got 3 columns of data in the data set. Well, what can we do with this stuff? Well, the first thing we'd like to do is I'd like to use this to replace a table calculation. And probably the simplest table calculation that you're familiar with is calculating the percent to total. And to do it, you just very simply open up this quantity, and we're going to look at these LOD expressions later. But I can do a quick table calculation of percent of total, and it looks something like that. And I want to put the quantity back in there so we can see this data. Now, if you've ever worked with table calculations, you know there's limitations in what you can do with them. And very often I want to replace this type of calculation, a table calculation, with its LOD equivalent. And to do that, what I'd like to do is I'd like an expression for that total. Well, let me show you what, first of all, the table calculation looks like. You take a look at the table calculation itself. It's the sum of quantity divided by the total sum, and total is a table calculation. And I'd like to get this total as an LOD and use it in a formula rather than using the table calculation itself. Well, I can write a table, or I can write an LOD that looks like this. That says fix the sum of quantity, and it's going to give us the total sum. And if I drop that into the workbook, you can see here's 152, which was our total. And now I have that as another layer in my data set. And we can calculate the percentage using the LOD. We've replaced that total value that was here with the LOD that we just wrote. But you notice here we have the sum of quantity, and we're dividing it by the LOD, and we have to aggregate the LOD. When we place the LOD into our data set, it goes in and it expands our data set, it restructures our data set, and it gives us a value that in itself is not aggregated. So we can aggregate it any way we choose. So here we can use it to replace the table calculation that gave us our percent of total, and we can use it to calculate our percent of totals. Okay, well, that's kind of cool. What other types of things can we do? We can use that same type of calculation to calculate weighted averages. I told you I'm an engineer, and engineers like to look at weighted averages as opposed to just straight averages. I guess business people like to do that also. That same data set, we can take a look here. We can take a look at the simple average of all these values, and it works out to 986, and the grand total works out to 1067. But I know that there's a whole lot more quantity sold with customer 1 than there is customer 2. So we ought to weight the value of what customer 1 bought differently than customer 2. And we can do that using a series of using a calculation that's going to take this value, the average value, and multiply it by the quantity. And I'm going to use an include statement to do this. And this include statement just simply says, take the sum of price times quantity, take the price times the quantity, take the sum of that. And I want it and this include statement allows you to drill down within this hierarchy here to any level that we choose, stopping at customer. So I can look at each one of these levels, and I can take a look at the quantity times the price to produce this column right here. And then to calculate the weighted average, what I want to do is I want to take that value and divide it by the quantity. And it's just simply using the sum of the LOD we just calculated divided by the sum of the product quantity only. And we calculate that the weighted average is not 1067 total, but it's $9.14. Well, we've been able to use LOD expressions to do math. There are other things we can do with LOD expressions. I don't know about you, but I see questions come in all the time where people want to find the first sales date or the last sales date, or what were the sales on the last date by category, or the first date by category. Well, LOD expressions are going to help us do that also. What I'd like to find is the first day that each one of these subcategories was sold. So we can write an LOD expression in terms of the subcategory. For each subcategory, return the minimum order date. Well, order date, the minimum order date is going to be the first order date. So that's the date that we're looking for. But with dates and with string tables or string dimensions, there's only 5 types of aggregations that you can use. You can count them. You can count them distinctly. You can find the first or the minimum. You can find the last or the maximum, or you can use ATTR. But you can't use ATTR attribute in a LOD expression. You use ATTR when that value can have multiple, when that dimension can have multiple values. Well, you can't have multiple values inside a LOD expression. You need to identify either you want the min or the max. Well, here we wanted the min. So now we can take a look here and we can say, well, geez, accessories, their first order date was January 9th, and then the copiers weren't sold until May 2nd. So now we know the minimum of each date, or minimum for each category. Well, what can we do with that? Well, we might want to know who the customer was who bought on that date. And we use this type of calculation very often when people are looking for the min, the first sale or the last sale, or the first time a product was introduced, for example. We just take the order date and we compare it to the minimum order date for each subcategory. And if that is true, then we capture the customer name. Once again, I want it by subcategory, and I'm going to take the minimum value. I could take the minimum or the max, and we end up identifying who the customer was. So we see that Melanie was the first to buy accessories, and Carrie was the first to buy copiers. We could obviously do the same thing and find what the value of that order was. The same calculation. We just do sales, and we have to do sum of sales so that we get the total sales value. So now we're able to identify not only when the first date was, but who bought and how much they bought. There's another way of doing this, and I just want to show you that. We could just simply take the first order date and use it in a filter so that if the order date equals the minimum first order date, it will return a true. And we can use that as a filter. And then I'm going to show the filter here and set it to true. And then we can just apply any value or any dimension or any measure in here, and it's going to return that value on that first order date. So now we've been able to use LOD expressions in a couple of ways. We can use them to do some mathematics. We can use them to find the first or the last. But there's some other things that we can do with them. I've got a data set here, and this data set just has a number of people, a large number of IDs, and for each person, there's a value. And what I'd like to do is I'd like to make a histogram out of this. I'd like to see how this would plot as a histogram. So I'm going to use an LOD to do that. And I'm just going to use this expression that says fixed ID equals the sum of value. And you're saying, well, isn't that just the number that you've got there? And sure enough, it is. I could drop that in there. And it's, they're the same values. Well, why would I want to do this? Well, I want to do this so I can take this value and convert it to a dimension. And I just took that value and I right-clicked it and I dragged it up to the dimension part of the data frame. And that's the part above the line. You saw it change to a blue pill and it's become a dimension. And now I can take that dimension and I can put it on columns, for example, and it creates a histogram for me. And once we got the histogram, we can put in the sum of the value, or we could come back and we can count the number of users in each one of those buckets. So now here's an example where we were able to take a fixed LOD and convert a measure into a dimension. And you can only do that with fixed LODs. You cannot do that with include or exclude. And then probably my favorite use, or my most frequent use of LOD expression, is in calculating year over year or period over period type analysis. And if you've ever gone out to the forum and you've written a post out there, or you've asked a question out there that says, I'm trying to do a year over year analysis and it's just not working out right. I'm using a table calculation and I've got a blank column, and you got an answer back. It probably came from me that said, no, what you really want to do is you want to use LOD expressions. And we're going to use an LOD expression. The first one we're going to look at here is I want to find the last date in the entire data set. And we've got a type of LOD that lets us do that. And I want to show you what this LOD looks like. You'll see that we have the curvy brackets on either end that says, hey, this is an LOD, but there are no dimensions here. And this is what's known as a table LOD. You'll hear us talk about, well, a table LOD is a calculation that pertains to the entire table. And this calculation will look at the entire table and return the last date, the maximum order date. So we're going to base our year-to-date calculation versus prior year-to-date on the maximum date or the last date in the data set. Okay. Now to calculate the current year-to-date sales, let me just line this up so you can actually see what's going on here. All we're going to do is we're going to check to see if the order date is in the same year and it's less than the max date. And to do that, we're going to use a date function called date trunc, and date trunc returns the first date of a period at the level of the date part within the argument. So in this case, it's going to take a look at the year level. It's going to return January 1st for the order date. And if January 1st for the order date is the same as January 1st for our max date, we know it's the same year. And then we're going to also check to see if the date trunc of the day, if each day in that year is less than the max date in our data set, then we're going to record the sale. Okay. We can do the same thing for prior year sales. And the only difference we're going to make in this calculation is right here. And I'm going to blow this up again so that we can see it. The only difference is we're going to use, instead of just the max date, we're going to decrement that max date by 1 year. We're going to look back 1 year, and if it's the same year as if the same date in the prior year, and we're going to use that in the year calculation. We're also going to use that in the day calculation. It will return the prior year sales. And then calculating the difference is nothing more than doing the sum of the current year minus the sum of the previous year, or the percent difference is just dividing that value by the prior year. Well, you're probably saying to yourself, well, geez, Jim, that's an awful lot of work. Why do I want to do that if I can do that in a table calculation? Well, when you use LODs to calculate those values go into your data set and they're available for use elsewhere, and they're entirely portable. You can take them from one sheet to another sheet. You can do a graph like this that would show the current year or prior year sales, or I could just take the summary and create a summary table of the percent difference. Because the LOD is in the data set, I can use it on any sheet that I choose. You can't do the same with table calculations. Well, we took a look at LOD expressions. We found that they're actually creating layers in your data set. They're not aggregates in themselves, so they can be used in any other calculation. And they've got a lot of different uses. I want to turn over now and I want to take a look at table calculations. In table calculations, and I find particularly with users who have a background kind of like mine, where you came out of using a lot of Excel or maybe Google Sheets or some other spreadsheet calculator, there's a tendency to feel real comfortable with a table calculation because you're used to looking at a data table. Now, this is the one time you're going to hear me say, okay, I want you to think about the data table as it looks in your view, not the detailed data. You'll hear us talk about the underlying data table. The underlying data table is that detailed data table that you create for each one of your worksheets. The data table I want you to think about is the data table that you can actually see in the view. And when we think about the table calculations, we talk about two concepts. One is scope, and scope is how much of that data table is used in each one of the calculations, and direction is what direction is that calculation applied. It's either applied across or down. Now let's take a look at this. Take a look at this very simple. I'm sorry, I got to keep moving these little blocks that are blocking things that I really want to get at here. Okay, I'm just using a very simple table. This is Superstore data, and we're just looking at three years worth of data, and we're looking at sales by month. Now, typically, you might want to come in here and you might want to say, hey, I'd like to know my percent of sales, and I'm going to use the quick table calculation to calculate that as we did before, the percent of total, and that data is calculated across the years. And by default, table calculations are calculated with direction across, but that's not the direction that we want. We want the direction to go down. Okay, we can open the table calculation, the one that we just created. We can open that up, and we can come down here to compute using, and you can see right here it says we calculated table across. We want to change the direction from across to down. And when we do that, we're now, and I'm going to put the totals in here again. We now see that we're calculating the percent of total down, and it totals 100% each year. So we've got this idea now. We got scope here being table, direction being down. And that's very important whenever you're using a table calculation. I'd like to take a look at how you write a table calculation and what some of these terms mean. Okay. And to do that, I want to use this table. This is all Superstore data. And we're going to use the sum of sales. We're going to use the sum of sales by the 4-year period over these 3 segments. And we'll start with this first table expression. And in this expression, we're going to do the window sum of the sum of sales. Well, first of all, table calculations are always aggregated. And this first argument is always an aggregate. And I want to show you what what options you have for the second option. The second option determines how you're calculating across the visible table. So we're using sum, but you could use average or count, and there's some light statistics in here. You could use percentile or whatever across the table that you're dealing with. The sum of sales here we're talking about, and we're going to just take a real quick look at this. Because once again, we're talking about the sum of sales being from this 10,000 record data set. We're saying as you go from this 10,000 records to the 12 values that you see here, I want you to use sum to get there. So we're summing those 10,000 records to get to the 12 values you see there. And then to do the window sum, we're going across these 4 values because I'm calculating across the table to give the total of those 4 values, which is this 1.16, or those 4 values, which is the 706, and so on. Well, if I can do that, I can also look at the average of those 4 values. So I take the window average of the sum of sales, and the average of those 4 values is 290, and the average of those 4 values is 177. So this part of the expression, the function itself tells us how to aggregate the values that we see in the table, the visual table, not the detailed table. This part of the expression tells us how to go from the detailed table to the table that we see in the viz. And if we could take a look at the average sales, and we can also I'll find the right one here in a second. Okay. We can also sum the average. We can take the window sum of the average sales, and the sum of those 4 values is 208, and the sum of those values is 291. So when we talk about table calculations, you want to think of how you're aggregating the detailed data to get to the summary level, and then you want to think about, now that I've got those values on the summary level, what do I want to do with them? How do I want to look at those totals? How do I want that window function to work? Well, we have users that come to the forum and they ask a number of questions, and we see this type of question come up on occasion, where I've got the sum of sales and I got it by month. And the first thing our users would like to do here is I'd like to look at the running total. I'd like to take this value and add it to that value and get 19, and then that value and add it to, and I'd like to calculate that running total down the table. It's very easily done. We've got a function that allows us to do that. Running sum is a table calculation, and you might have guessed we can do running min and running max and running average and a whole variety. But the running sum just calculates the total going down the table. Now, once I've done that, I'd like to take the difference between these values. I'd like to know what the difference between 2018 and 2017 was. So now I want to go across the table based on the values of this table calculation. And to do that, you nest one table calculation inside another table calculation. Table calculations are calculated last in the order of operation. You can use any other type of calculation in a table calculation, but you can't use a table calculation in anything but another table calculation. So now if we want to calculate the difference across, we're going to use an expression like this. And I'm going to show you here in just a couple of minutes what these lookup functions look like and what they actually do. But all this says is I want you to look at the value in this current cell and take the value from take from it the value in the preceding cell. That's the -1. Look one cell back from the current cell, look one cell back and take the difference in those two. And you get a value of 4, you get a value of 11. So we're able to nest one table calculation in another table calculation. And then you can do that repeatedly. And I'm going to show you some use cases where we do quite a bit of that. And when we were talking about LOD expressions, I said, look, you can use an LOD expression. It's not an aggregate in itself, so you can use it in any other type of calculation. And this type of question comes up very frequently, where a user will say, hey, look, I would like to find out for each one of my subcategories by segment, by year. I'd like to find out what was my best-selling subcategory. I'd like to see how that varied across segment and how that varied across years of sales. Well, that's a pretty involved calculation. Where we have to start first is with an LOD that goes back, and I'm going to go through this. He wants to look at each segment, that's this right here, each subcategory, and each year of order date. And yes, I can use a year of order date as the dimension in my LOD calculation. So in words, I would say, well, take all the combinations of segments, subcategory, and years of order date, and that's 204 points. And for each one of those 204 points, sum the sales. And then save it so I can use it later. And that's what you see there. There's 204 values. They have been totaled, summed from the 10,000 records that are the detailed data set to form these 204 totals that now we're going to use. The next thing I want to do is I want to calculate a ranking for each one of these. And ranking calculations are all table calculations. To determine a rank, you have to look across records in a table, so it has to be a table calculation. In a ranking calculation, we're just going to sum that LOD, has to be an aggregate, so we're going to sum that LOD, and we're going to, we want it descending, we want the values descending, we want the highest value first. And I can place that in our table. And we're going to mess there for a second, and I just want to hide these. And sure enough, what we see is that the default kicks in, and Tableau gives us the rank across the table. Well, that's not what we want. We want to go down the table. I can open up that pyramid there and go to Edit Table Calculation. It's a very useful tool. And in this tool, it will show us not only the scope, but the direction of the calculation. The highlighted value gives us both the scope and direction, and you can see we're going table across, and that's not what we want. I'm going to come down here to specific dimension, and I'm going to click all the values, and now we're looking at the entire table. There's 204 values. This is the least value. That's the greatest value, but it's not what we want. What we would like is that every time this segment changes, we would like to recalculate that ranking. So we can restart this expression every segment. And at that point, this looks like what we want. And you can see here, we can see, well, phones were first for consumers and corporate in 2017, and third for office, and that changed in 2018. So it's got everything we want, except it's pretty difficult to read. It's pretty tough to see what's going on. Well, we can also do an additional thing with another table calculation. And all we're doing here is we're taking a look at the window min of the ranking, and the window min going down will be 1. We're looking for the lowest rank or the highest sales. When it equals the rank of the LOD, I want to color that square yellow. Otherwise, it's going to be colored blue. But when I bring that to color and do a little sizing in here, this is what our table would look like. And now here it's pretty easy to tell what the best-selling items were by segment, by year. Okay, we've been able to take a look at the mechanics behind table calculations. They also do one additional thing. They allow you to navigate within the table. And this is very similar to offset in Excel, if you're familiar with offset in Excel. And there's 5 functions that you can use: first, last, index, lookup, and previous value. First and last refer to the first row or column in the data set. Last is the last row or column in the data set. Index just starts counting across the columns, 1 through whatever, or down the rows, starting at the top. Lookup allows you to go from your current location to another cell and retrieve a value and bring it back. And previous value looks at the immediate preceding cells. Well, let's take a look at a couple of these things and see how this might work. The first I'd like to look at is the lookup expression. And we used this before. And all the expression does is if I'm starting at this location, I want to go to the measure that's identified as sum of sales. And that's this whole block here, okay? Sum of sales. If I'm starting at this location, I want to go to the comparable location -1. And -1 across is going to be to the left. So this value is going to equal that value. That value is going to equal that value. That value is going to equal that value, and so on. Here to there, there to there. Well, if that's what lookup does, what does previous value do? Well, previous value looks to the immediately preceding value in the same row. So previous value here returns the same value. Previous value looks back in the same row, in the same row, in the same row. So there's a couple of things that you can do with previous value that become very useful. I can use previous value to calculate a running total and a running product. And to do that, I thought that I would just use an index to create this chart. It's a little bit easier to see than those large numbers, if you will. And here I just created an index, and all index does is count across the rows. So I got 1, 2, 3, and 4 across the 4 rows. Now, what I'd like to do is calculate a running total using previous value. Okay. And to do that, I take the value of the index and I add it to the previous value. So 1 is a starting value, and 1 plus 2 is 3. And 3 plus 3 is 6, and 4 plus 6 is 10. So we've calculated the running total. We can also calculate the running product. And the running product, as you could guess, is the value multiplied by the previous value. So 1 times 2 is 2, times 3 is 6, times 4 is 24. Okay, so previous value gives us opportunities to either create products or to do a running total. Well, how would we use these? Let's take a look at some use cases. And very frequently, we'll get a case where a user has written in and he says, look, what I'd like to calculate my top N items, and I'd like to calculate the total of those top N items. And to do that, you have to use a number of nested table calculations to make that happen. I started with just a parameter, and all this parameter is used for, it's just an integer, and all this parameter is used for is to tell me how many N is the top N. I've got it set at 2, so he wants to look at the top 2 values. And then we make a couple of additional calculations with that. The next one is a ranking function, and we've seen ranking functions before. We want to calculate the rank based on the sum of sales, and I want it descending. And here, we open this up so that we restart that calculation every category. And you can see here, our editor showing us both scope and direction is showing us for the furniture, I want it to start at 1, and then when you get to office supplies, I want it to start at 1 again, and then phones, I want it to start at 1. Now I'm going to use that calculation in a filter that I want the top N to be less than this parameter value. And if that's the case, it's going to return a true. And then I'm going to calculate a running total based on that calculation. Now, up till now, we've been using, in this first argument, we've simply put in a sum of sales or sum of a measure or average of a measure or whatever. You can use expressions in here too. This is just a conditional expression and says, look, if the rank, if this filter is true, then return the sum of sales, if not n. And this part is our starting position. Our starting position is the first position in the category, and 0 is the cell location where we are. So what this calculation does is it calculates the sum of those two values. Now I'm going to change this to a value of 3, and you can see that now we're calculating the sum of these 3 values to get that. And I also want to incorporate a filter that I put in here, our rank filter. We've got true and false. And I want to show you what this calculation does. What we're doing at this point is if this value is less than our parameter value, I want to include it in our running total. So we get the value, we get a running total here. This value is those two, it's those two. And once this value turns false, I don't want to do any more addition. So essentially we've stopped doing a running total and our n equals 3 value. And then we just come back and we use this rank filter to hide the values that we don't want to see. And if we don't want to see this also, we can just hide it in our calculation. So we've been able to calculate not only the top end, but we've been able to calculate the total of the top end. Well, what other type of use cases do you have available with table calculations? Very often we get people who want to know how many consecutive values are there in a data set. And this happens quite a bit with charitable organizations. They say, well, look, I've got a list of donors and I want to know how many consecutive years they've been donors. So we've got a data set here and we've got 3 donors. We've looked over a number of years and we can see the value of their donation over the 3-year period. What I'd like to do is I'd like to use a table calculation to identify when they have given and when they haven't given. I'm not concerned about the amount of the gift. I'm just, did they give or did they not give? And we're going to look up a value. And if the sum of the gift is greater than 0, I want to put in a 1, if not a 0. Or a no. And that would look like this, and that's fine. What I would like to do now is I'd like to count those consecutive years. And to do that, we take a look at this table calculation. I'm going to nest it in a lookup expression. And if that's greater than 0, then I want to do this running sum based on the previous value that we identified before. So if it's greater than 1, add it to the previous value. If it's not greater than 1, insert a 0. And we can do that, and we can see it's calculated across, and we need the direction changed to down. And then we're just interested in seeing the max value. So I'm going to use another table calculation. So now we're 3 levels down in the nesting of the calculation. We're going to look at the window max. And that has to be calculated down also. Okay. And what I don't want to see all this table, so all I want to do is I want to put in a show hide filter. It says if last is equal to 0, show the values. If not, hide the values. And I only want to see the last values in the table. So we can see that John his max is 3 years, and Mary's is 2 years, and Robert is 3 years also. Now, there's one final comment I want to make about table calculations, and we see this come up a lot, particularly with people, scientific people who are trying to do statistical analysis And they're ending up using things like standard deviation or some of the other light statistical functions. And they'll say, hey, look, I created this calculation for the standard deviation, and it's just plain not right. And you get into their data book and their data set, and you see that they've used this calculation. And this is the standard deviation at the detail level of the data. It's a standard deviation at that data table level, the detailed data level. So if we looked at the 10,000 record, then those that are accessories, and we took the standard deviation of those, it's 335. Well, what they really wanted was a standard deviation of all of these values. And that, and this is not a great surprise, is a table calculation. And we take the standard deviation from the top to the bottom, and the standard deviation of all of that is 102. Well, that's what I wanted to share with you today. That's what I wanted to go through today. We took a look at LOD expressions. We took a look at how they create layers in your data set and how you can use them for a lot of different calculations because they're not aggregated in themselves, and you can use them in any form of calculation. Table calculations, on the other hand, work with the visual table that you see. The first argument, the first argument is how you're going to sum the data coming from the detail to the summary level. The function itself is how you want to aggregate the data based on the visual. I don't know if I have time for questions. Are there any questions that out there that I might be able to answer at this point? I haven't been looking at the chat, so I really don't know.
There wasn't any questions put in the chat yet, but comment that it was really interesting.
Okay, very good. Very good. Mary, I'm going to turn this back to you because I know we have another speaker tonight, unless there's any questions. Okay, back to you, Mary.
All right. So thank you very much, Jim, for speaking with us today. If there are any questions, as Caitlin had mentioned, go ahead and drop those in the chat, and we'll share that with Jim after the meeting if there is anything still remaining. But for now, we'll go ahead and turn it over to Jupiter to tell us a little bit about some of the Tableau new features and what we can look forward to with this recent release.
Thanks, Mary. Much appreciated. Can everyone hear me okay? Can I just get a sound check from one of the presenters to make sure?
Yep.
Awesome. All right, great. So hi, everyone. My name is Jupiter Angulo. I am a solution engineer with the Tableau team. So I do work here at Tableau/Salesforce. And today I have the great pleasure of presenting to you guys on some of the new features that we have here at Tableau. Oh, sorry, let me just get this in the right screen. Not sure why that's happening. One second. Might have to just do it here. That's okay, that'll work. Okay. So a little bit about me before we get started. So I have been in the analytics space for most of my career. I started out in the insurance industry. After that, I transitioned into more of like a sales type role. So sales support, again, solution engineering. I'm not the one trying to sell you stuff. I'm more the one doing demos and showing you all the cool new features that we have or how to do things. I've been doing that for the last 3 years, 1 year here at Tableau, 2 years at a previous company, a competitor. And so my background is analytics focused. I did work with Tableau, open source tools, and a bunch of other, ETL type tools in my past life. So pretty well versed in that. The goal today isn't really to run down like 20 different what's new features, because I think a lot of times that can get dry, boring. If I just spend too much time, or I don't spend enough time walking over them, then it just kind of becomes lost. So what we really wanted to accomplish here, and especially because wanted to make sure we had time for questions and to really go into details, we're only going to walk through a couple of new features that I'm going to talk through. And again, they may apply to you, they may not, but I think you can definitely see some of the value that they could have no matter what type of role you're in your Tableau career. So with that, the first feature, I apologize, that's out of order. The first feature I'm going to talk about today is centralized row level security. And honestly, just row level security in general. So let me kind of provide a little context on why we did this and what the goal is. So row level security, I think, has been out for a while now. It's been out for about a couple of years or so. I don't know the exact time it came out. And effectively, that was a way for Tableau desktop or workbook creators to be able to essentially create their dashboard in a way that whoever views the dashboard only sees data that pertains to them. And that could be done with a couple of ways. You could use user calculations. So there's actually calculations that basically look for a person's username when they sign in and look at the dashboard, and then use that to filter. And you can also use data source filters on the data source when you load it into your Tableau desktop. So there's a couple of options. Now, what we have seen in the last couple months that we've implemented this and our customers have begun to implement this is that essentially it's very hard to scale this and manage it because it becomes unsustainable. It's at a desktop level or a workbook level, I should say. And at the end of the day, it's very hard for individuals to keep track. So, and it's even harder for an IT group to keep track of this. So that's why we came up with centralized row level security. This aims to kind of solve for that by basically doing the row level security at the source. So I'm going to kind of show you how it's implemented. And in doing so, you'll also kind of see how you could maybe take this row level security calculated fields or calculations and apply them to your workbooks as well if you're doing this at more of a workbook level. So it's kind of a nice 2-for-1. And I'm also going to take advantage and talk about virtual connections because they kind of go both, they both go hand in hand when it comes to kind of managing your data at a higher level for an enterprise. So here you can see I'm pretty standard Tableau server. I'm going to go into my Explore page. And when I click on new, this is again what you'll see with virtual connections. You'll see I can click on this. It's called the virtual connection. Now, this is part of a data management add-on that we have. So if you do have data management, you will be able to see this if you have the permissions to create connections as like a creator or an admin. So when you go in here, you'll actually come to a new page. It has a very sense of familiarity. Again, if you've used Prep before, even like it gives you the same vibe of desktop. But essentially what you're doing with the virtual connection is that you're essentially creating a copy of a dashboard or a database that you may have for your company and providing it to your users on Tableau as an extract. So some of the value that we see here is if you think about Amazon, AWS, Baba, Google, Azure, they're cloud storages, and essentially the way they charge, for data is ingress and egress. So loading data, from the cloud itself, it comes with costs, and they can add up depending on how much data is being extracted and how often it is, et cetera. So what this does and what this aims to do is say, okay, we're going to take maybe the top 5 or 6 most used data sources by our Tableau users, and we're going to make them available extracts that they can load directly from our Tableau server and not have to worry about querying the cloud sources. So they can set up a schedule to refresh these connections. So maybe they want these to be weekly refreshed, maybe daily, whatever the business needs are. That's how they would be set up. But for this case, we're going to go ahead and actually go into one of our test servers here. Just bear with me as I authenticate here. So again, this is the process you would be going through. Once you sign in, you'll be able to see, again, like if you're working with Prep or any sort of other database connector on Tableau desktop, the very similar look. Here I'm going to go into my Superstore data, and here are all the tables that I currently have in my Microsoft SQL Server. Again, these are all located there, and if anyone made the direct connection to SQL Server, they can pull it themselves. But I know for a fact that my customers use a lot of the orders table and the returns tables. So I can load those in and start creating these tables to kind of apply to my virtual connection that people then can connect to. And I can do a couple of things here. I can see a preview of my data. So I can take a look to make sure it's what I expected. I can do live only. I can switch to extracts. And what I can also do is I can set up data policies. So this is where your centralized row level security can come into play. By setting up a data policy, I can then control basically what is seen and what isn't. So let's say, I have this here and I have my orders table. Oh, apologies, let me do one thing. I haven't actually added my people table. Here we go. So the goal, or the kind of the way that row level security really works is you have to kind of have something that you can use for Tableau to recognize who can access what. So that's how we're going to do it with this people table, which I can show you here. It kind of just shows, like, let's say these are the regional managers for each of these regions. So when they load up the Tableau dashboard, they or even want to load up Tableau data to do analysis, they should only be able to see their region. We don't want them to see everyone else's regional data, because it's pertinent only to them. So once I add a policy list, I can actually do it a couple of ways. So I'm going to show you one way that's not really row level security. It's more like filtering down to whatever needs to be done. So if I just do this, and then I can say region is equal to, let's say West, right? Okay. So this is a quick filter that I've created. It's a policy condition on region. I'm going to publish this data source only for the West team, and I only want the West team to see it. When I apply this, I'm going to filter it, and essentially you're going to see now there's only records for the Western region in this data source. So I could go ahead and say I'm happy with this, I'm publishing, but obviously we want to see row level security. We want to see how you can use it for users. So what we can do now is, let me go ahead and remove this. I'm actually going to add my people table as an entitlement table. And what this does is, this is the table that I'm going to use to kind of reference my original table in question and basically filter out and show how security can be applied. So the first thing I have to do is just make sure I find the connection. Again, region is my connector in this case. So once I have region connected, I can now start to put in anything I'd like. So in this case, I'm going to show you two different ways to do it. So the first is, let's say you don't want to go down to the user level, because again, it can be very tedious, like especially if you have thousands of users, it's very difficult. You could also go down to group level. So let's say you have a finance group, an HR group, and this is HR sensitive data. You don't want your, finance team to be able to see the HR sensitive data. So we're going to actually use the executive group that I've created in my server is member of executive. And I'm going to switch to my executive, and it looks like oh man, all right. Having a little issue here. This is still a little buggy. I apologize. It was working this morning when I did it, but what it should show is that because Chuck McGee is actually an executive as part of the executive group, he's the only one who would be able to see the data in here. And the reason I can see that is because I'm actually previewing it as Chuck McGee. So I can see what the user would see if they were to log into this. So I do apologize that this isn't actually filtering properly. And if you bear with me, what I'm going to try to do is actually log in again and see if that resolves the issue. It's probably because it's been sitting there all day. So let me just try one more time and see if I can resolve it. I do apologize here. While I'm doing this, is there any questions in the chat so far, or should I just try to get this loaded as soon as possible? Okay, I will take that as a no question so far. All right, let's try that one more time and see if it works. This is what I love about demos. Sometimes it's always in the worst time that they don't work. And so it's very much a scramble to try to get everything set up again. but let's give it one more shot. And if it doesn't work, maybe I can send a recording out of what it's supposed to do in theory when you're working with it. So let me do this again. Apologies, region, okay. So is member of executive. Okay, cool. So we have that in place. Now I'm going to go in again and I'm going to apply with the policy, and I'm going to preview it as Chuck McGee because he is part of the executive team. Okay, now let's go into orders, preview data, fingers crossed. Oh, shucks. Oh, well. Unfortunately, having some internal issues here. I do apologize. Let me try just one more thing. Let's try with the, well, I'm going to show this anyway. So the other function that we have is username. And this essentially allows you to basically check the username of the person who's accessing the dashboard. So it's a function built in Tableau. And the way this does it is it'll reference it to your people table. So we have here, let's go off here for now. We can see, now I'm just having table problems in general. So weird. Okay. So basically when you filter like this, it'll look into your people table and it'll say, all right, who is the person who's logging in? It's Anna Andriotti. I'm only going to show her results for the Western region. I'm not going to show her anything from the East or the Central or the South. And this is happening at a data source level. So no matter what dashboard is created, your users who are allowed to see things will see them if you use this data source to kind of create those data to those other dashboards. So that's kind of some of the power of row level security. And this is again at a data source level. These same calculations could be applied to your workbooks and essentially would function the same way. The only difference then is though that would only apply to those workbooks. And so if someone else created another workbook similar to yours, they would have to apply the same security parameters or else it would defeat the purpose. So that's kind of where this comes in handy and being able to kind of show. So like if we're happy with this, username's equal to person, I would publish out the data source. So I'm going to call this Superstore Central Level Security. Let's do that. I'm going to put it into my demo project and I'm going to publish. And it's as simple as that. And I can guarantee you it actually works when you go in and actually view it as a user. You would be able to see that you would only see the data you're allowed to see. So again, only Cassandra, Kelly, Chuck, and Anna would have permission to look at data, and they would only see data pertaining to their region. So that's kind of like an overview of centralized low-level security. And again, row-level security in general, how it can be applied, some of the functionality. There's advantages, disadvantages to both. Again, this is more at a higher level. It's more something your data steward would do. But as a Tableau analyst yourself, you can definitely apply your own row level security using the very similar functionality as I'm using here. You just need to have a way to kind of apply those filters. So you have to have either groups or users, that's kind of how you would be able to apply it. So the next thing I wanted to show you guys, which you kind of saw here, was the Workbook Optimizer. Now, this is actually a very new feature that just came out with 2022.1. So again, if you're on the latest and greatest, you should have it. But once you are on it, I think it's going to be very handy for us Tableau developers. And I can kind of provide some context why, right? You've probably created Tableau dashboards in the past and you've published them up to Workbook or to server, and suddenly you start getting emails saying, hey, this workbook's really slow, it's taking forever to load, this filter is taking so long, what's going on? Now, wouldn't it be great if instead of having to go and basically dig down the issue yourself, you could just run a tool to kind of give you some tips on where to improve and where to take action to actually improve your workbook's performance? Well, with Workbook Optimizer, that's exactly what we're trying to do. I should mention this is in its principal stages of actually this is the first time we've released it. So in terms of robustness, it's not quite, the level that we would like. And for some reason, this bar is in the way. How do I move this? Okay, there we go. So this is very familiar for you guys. When going in to publish a workbook, there's a couple of options here. I'm going to, and this is a new one you'll see, is Run Optimizer. So if you click on that, you'll see that this is automatically run within seconds, and it does 12 tests, 12 very common, these are the first things we would look at if we had complaints of a slow dashboard. These are the things we would look at. So let's take a look. These are take actions. These items basically won't impact your workbook functionality, and they're just things that are really good to do in general when publishing up workbooks to the server. So unused data sources. I have this data source. It's not used in the workbook. It shouldn't be in there, right? So I have unused fields. These fields probably worth hiding because, again, if they're not being used, then every time that someone is taking actions in my workbooks, they're being queried needlessly. And also this reduces size of extracts to make things more efficient on your server. And finally, non-materialized calculations. Again, multiple data sources have not been pre-computed. So in this case, if you push the calculations to the data source, this is going to make your querying a lot quicker, and it's going to improve the performance. It also provides you things that could potentially require a trade-off in the workbook where, for example, number of data sources. It has 7 of them. And this is kind of where it's up to your best judgment. You have to say, okay, could I separate this into 2 different workbooks to lower the number of data sources in the workbook? Sure. Will it accomplish the same task that I'm trying to do? Yes. All right, I should do it. No, it's going to have to be what it is, right? Number of visible worksheets. Again, if it's required, if it's going to make or hurt your workbook's value, then there's no point. Same with calculations. Could you go in here and potentially change the calculation, maybe improve it? Sure. But again, the last thing we want to do here is say these for sure do them, because they may change how your workbook's being done. And finally, the other 6 things that it tests for are here. So at the moment, there's only 12 that it does. You could go in and take these changes. And again, so at the moment, you do have to do these changes manually. We are working to kind of make this a little more of a automatic process that you could just click a button and it would do it for you. So look out for the next couple of releases as we work to improve the Workbook Optimizer. But that's kind of the gist of it, really. So once you've kind of made your changes, you can rerun the optimizer and see if the changes have been applied, and then publish up your dashboard. So it's just a good second check. I'm sure all of you have really good, workbook etiquette. So this is just pretty much oh, maybe there's one thing I forgot to do, and it'll remind you. So really cool feature, just to help us be better Tableau authors, and ultimately, lead to less emails from our users asking us why this workbook takes 30 seconds to load. So with that, I know we're at 5:20. I want to make sure we have time for closing, and if there's anything closing or if there's any questions, more than happy to answer them now.
Looks like there were 2 dropped in the chat questions for you. One, the first was about virtual connections. Are they database specific, or can you go across databases?
Sorry, can you repeat that, Mary? Or I can see if I can take a look as well. Let me see, where is my, here we go.
It was if the virtual connections are database specific.
Oh, I see. So can you go across databases? That is a very good question. So I believe at the moment, they may be database specific. Let me take a quick look here. If we can add an additional connection. Yeah, for the moment, I believe we are focused database specific. So you would have to create these as, essentially what they are is they're kind of mimicking your database, right? You would pull in the tables that you need to, and then from there, you could then create prep flows from those tables to kind of create those combined database tables that you would need to do. So you could use Tableau prep to do that second step from those virtual connected data sources. But I would think of these virtual connections more as like, this is a pseudo Microsoft SQL database, and this other one could be a pseudo Snowflake database.
And then with the Workbook Optimizer, is that going to be part of the data add-on or part of the standard release?
That is a standard release feature. So Workbook Optimizer is on Tableau Desktop and Tableau Server.
Does anyone else have any other questions? I guess we'll go ahead and just the last few minutes, anyone can come off mute. We can open it up for just general questions or networking. And but give a great big thanks to both our speakers, and thanks to you, Jupiter, for taking us through some of these new features. If anybody has any questions, again, please drop them in the chat or take yourself off mute and go ahead and ask them. Thanks.
Yeah, I'm having some trouble stopping sharing here. Do you mind kicking me off sharing, Mary, or I just don't know if I still am or not.
Let me see if it'll let me do that.
I hid my bar and now I can't find it. There we go.
There you
awesome.
go.
Thank you.
Okay.
Thank you, Jim and Jupiter, for all the information today. This has been great. I can't wait to go through the replay.
Oh, you're
It was
welcome,
fun being
man.
with you guys.
Yeah, we had a good time.
Are either of you presenting at the Tableau conference that's coming up?
I personally am not, but some of my coworkers are. And if that is something you all are interested in, I could definitely pass along some information. I know we're doing virtual and in person, so a lot of good virtual content too.
I'm certainly going to be at the presentation. I'm certainly going to be at in Las Vegas. So if any of you there, stop by. And if I could put in another plug for the newbies group, we are meeting the 26th of May. And Klaus and I are going to go through the order of operations, which, as I mentioned before, I think it is probably the single most important thing you have to understand as you're making that transition from Excel spreadsheets onto Tableau. And we're also going to have a special guest speaker. Sarah Battersby is going to speak on maps. So we'd love to have you out there.
All right. Well, if there aren't any more questions or discussions, we can give everybody 5 more minutes of their day back. It was great to have so many people stop by. Thank you again so much for the presenting, both Jim and Jupiter. I know I found it very informative, and lots of thanks from the rest of the group. If there's not anything else, then I'll say bye to everyone and have a good time. See you the next time we see you.
Thank you all.
Thank
Everybody.
you.